So last time we talked about congruency statements for triangles and any other polygon. Now, we can use that stuff to prove triangles are congruent. However, that just means that we have to have at least 3 angles stated congruent and 3 sides stated congruent, and then the triangle stated congruent. That's a lot of steps. So fortunately, there are a few shortcuts that we can do. So the first type of triangle congruency that we're going to talk about is called side, 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 or we'll shorten it down to SSS. Now, side, side, side congruent postulate says that all 3 sides are congruent. So I can say PC is congruent with EC. I can say PF is congruent to EF. And then the one that we may forget about is CF is in both triangles. So it is actually congruent to itself. So CF congruent to CF. And as a reminder, this congruency that we just said is called reflexive property of congruence. It's been a while since we looked at it, because we looked at it in Unit 1, but we haven't seen it since. So side, 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 we've showed and proved that all 3 sides are congruent. Side angle side, or SAS, congruency, says that there are 2 sides that are congruent and 1 angle. Now, order matters, so the angle that is congruent is between our 2 sides that are congruent. So in this problem, I can say JE is congruent to HE. I can say ZE is congruent to DE. So there are our 2 sides. We just need the angle between them. So angle JEZ this angle is congruent with angle HED. So this would be our side angle side. That statement right there is our vertical angles. So we will be seeing a lot of reflexive properties of congruence in these proofs, as well as vertical angles in these proofs. Now, somewhat related to side angle side, we have angle side angle, or ASA. Angle side angle is congruency where we have 2 angles that are congruent in 1 side. But just like side angle side, the side that is congruent has to be between our 2 angles. So for example, we could say angle UTV is congruent to WTV. We could also say angle UVT over here now is congruent to angle WVT. So then the side between them, or the side that's shared between them in this case, is TV. So TV is congruent to TV again. Once again, this reason is our reflexive property of congruence. Now, our next type of congruency is called angle-angle side. Now, this one also has, or AAS, this one also has two angles that are congruent, but the side that's congruent is not between our two angles that are congruent. Now, this triangle is kind of hard to see, or these two, so I want to just redraw them off to the side. So we have triangle LJH. We have triangle KJH. The H on the first one is a mistake on my part. It's supposed to be an I. So to state our congruencies, I can say angle J congruent to angle J. That too would be our reflexive property. Something is congruent to itself. I could also say angle I is congruent to angle K. And then we need a side. So I can say LJ is congruent to HJ. Now, a trick to know if it is side angle side, not side angle side angle, or angle side, is if we take our writing utensil and go from one congruent mark, drag it to the other congruent mark. If we cross the side that is marked congruent, it's angle side angle. If we do the same thing for this one, going from one congruent mark to the other, we don't cross the side that is congruent. So this would be angle side. Now we have one last type of triangle congruency that could work. And that's hypotenuse leg. Hypotenuse leg is not that common. It's not that common because we have to have a hypotenuse. Now, it might have been a while, but hypotenuse is the side across from a right angle. So this only works for right triangles. So first we need to say that we have right angles. So I'll say angle G and angle D are right angles. Now your hypotenuse is the side across from our right angle. So in this case, FC and EC. Both of those have to be congruent. I'll put the single tick mark. And then a leg is any other side of this triangle. So I'll say GC is congruent to DC. So because we have right angles, our hypotenuse and a side length are congruent, So we can say these are congruent. Now there are two no-nos that we cannot have. This is going to be the first one. This type of statement where we say just the angles are congruent or angle, 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 triple A, does not show that they're congruent. It shows they're similar, which we'll look at next term, in the next unit actually. But it does not show that those two triangles are the same. So angle, angle, side, or angle, angle, angle is a no. The other one is this. This would be angle, side, side. Now, just reading angle, side, side, there's no cussing in math class, so you cannot have angle, side, side.